Okay, so we continue on the serviceability limit state. Okay, are defined as state that correspond to condition beyond which specified service requirement for a structure or structural member are no longer met. Okay, for example, settlement that is excessive for the purpose of the structure. It is not a technical statement. Okay, it is more related to what we call as a comfortness of the user. Okay. Okay. So the limit state consider the functioning of the structure or the structural member under normal use, the comfort of people, the appearance of the construction work. Okay, should be classified as serviceability limit state (SLS). Okay, we can okay. So means that in the Euro code, okay, 7, okay, he put we can found that this is a P there, so means that it's a compulsory, a mandatory to follow, okay, to make sure that we need to comply with the SLS as well, okay. Inconvenient, disappointment, and more manageable cost, okay, should be rare, but it might be uneconomic to eliminate them completely, okay. So this is cost due to the excessive settlement, okay, where they have uh, we can find that a crack, okay, happen, okay, settlement, okay, where there will be uneven height of the structure, okay, so there are cracks happening, okay, in the structure, okay, although it is we can consider it stable to be used, okay, however it's not a very comfortable, okay, for the user to stay or to use, for example, the bridge building, okay, for example, for this case, okay, so mean that they need to stop, slow the vehicle, okay, and then it's not very comfort to stay in this building, okay, although the rent is very low, okay. So that's why in the any design we should consider the SLS and also the ULS. Okay. So who should carry out geotechnical design? Okay. So part one, provide a useful although optional definition of categories of geotechnical structure. Okay. So for example, for the geotechnical category 1, they call as GC1, include relatively straightforward structure in which routine methods, including prescriptive method, may be used. Okay. While the code makes no attempt to define level of competency, experienced civil and structural engineer should be capable of preparing the geotechnical design basis for category 1 structure. Okay, so category 1, for example, a very simple structure, okay. Let's say we can consider, for example, a guard house, okay, it's very small, okay. So no need to have thorough site investigation. Only, for example, we can carry out for Macintosh Pro only, okay, to get the ground information, okay. So uh, no need to have a very competent or experienced civil and structural designer, okay. So somebody that is very good in construction also uh, can design for this what we call as this guard house, okay, for so in category under GC1. Okay. So a designer should be capable of judging whether a design situation is not more complex than allowed within the geotechnical category. Okay. So for the GC2, okay, actually this is GC2, so I need to change first. GC2. GC2. Then for the GC2, structure that involve excavation below the water level table but otherwise conventional structure without unusual risk are defined as GC2. Okay, so there is the common type of structure. Okay, where we, for example, want to have a foundation, so we need to uh, to 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 install, to build the foundations, okay, below the water table. Okay, so it considered as GC2. Such structure normally require some form of geotechnical characterization based on the field or laboratory testing. Okay, so then it required to carry out for the lab test. Okay, so we put under GC2. Okay. So the term of geotechnical engineer, geotechnical specialist, and geotechnical advisor are defined. Okay. It was suggested that design work on GC2 structure should be carried out by experienced civil or structural engineer. Okay. So that is for under GC2. So at least should rely on civil or structural, experienced civil and structural engineer. Okay. So then we have a GC3, which is cover situation that are considered unusual or are associated with high risk. Okay. GC2 project will typically involve advanced field or laboratory testing and numerical analysis. The Association of Geotechnical Specialists advocates the role of geotechnical advisor in establishing the design strategy of large project, and this would seem to be appropriate to GC3 structure. Okay, so for example, tunneling, okay, to build a tunnel. Okay, uh, or any high rise structure. Okay, should can consider under the GC3. Okay. So this is the fundamental equation for ULS. Okay, so we may learn it in the design for the shallow and deep foundation. Okay, I just provide a what we call as a brief explanation. Okay, because the detailed discussion will be made on the shallow and deep foundation lecture. Okay, so in here, okay, okay, we have a destabilized uh, uh, formula. Okay, and then this is the stabilized formula. Okay, so means that the stabilized formula should be greater than the destabilized equations. Okay, so E we define as the action effect. Okay, and then we have an action load. Okay, so this action load defined as the F. Okay, so then we have a material properties. Okay, as I discussed previously, we may apply the partial factor safety on the action, on the load. Okay, on the material properties. Okay, and also on the geometry. Okay, however, because we are dealing with the same geometry at the field, so A doesn't make any changes. Okay. So then we have a resistance. So D defined as the design factor. Okay. So from this fundamental equation, okay, so they include or multiply with a partial factor. Okay, so this partial factor we need to refer to the what we call as uh, to the Euro code or to the Malaysian standard uh, in terms of what is their value. Okay, So then, for example, partial factor, okay, then we multiply with the action loads. Okay, for example, we have the what we call as I need to check first, the terms. Okay, we have the permanent and variable loads. Okay, similar with what we the common British standard, where they have a dead and life load. Okay, so permanent refer to the dead load. Uh, then the variable is referred to the life load. Okay, so then we need to refer to the table uh, for the in the Euro code. What will be the number for the partial factor? Okay. So then for the material, okay, we need to divide, okay, with the partial factor for the material. Okay. For the A, the geometry, no need to multiply with any other partial factor, okay, because we are dealing with the same size. Okay. So the same goes to the R, okay, which is the resistance. Okay. Then the equation has been simplified, okay, into this um, value. Okay. Okay. Then uh, or they has simplified based on this equation. Okay. So at the end, okay, the equations, okay, has been derived, okay, based on this uh, full formula, okay, where they implement the alpha E, so the gamma E, okay, and for this case they divide with the gamma R, okay. So from there we can get the value of the full factor of safety, okay, by dividing the RD with the ED, okay. Okay, so for the design value of action, okay, the design value FD of an action F can be expressed in general terms, okay. So in here, FD, okay, the gamma F, okay, we may refer to the partial factor safety, okay, uh, to get the value for the uh, to get the value for the FD. Okay, so for the action we normally multiply. Okay, so okay, this is the same that we have discussed. Okay, in most cases the following simplification can be made. Okay. So for the action normally we multiply. Okay, and for the material, okay, so the design value XD for material or product property can be expressed in general terms as, okay, XK over gamma M. So for the material, we normally divide with the partial factor safety value. Okay. So the new is the random part of conversion factor. They call as a new. Okay. So alternative is in appropriate case, the conversion factor new may be used, implicitly taken into account within the characteristic value itself. Okay? By using gamma M instead of gamma M. Okay. So for the geometrical data, the design value of geometrical data such as dimension of member that are used to assess action, effect, or resistance may be represented by nominal value. Okay. So where the effect of deviation in geometric data, inaccuracy of load application or location support significantly for reliability of structure. Okay, design geometric data should be defined. Okay, so there will be an additional value should be added. Okay, but without having this kind of problem, so no need to apply, need to add the additional effect. Okay. So basis of geotechnical design. Okay, general design. Okay, section 2, page 9, 2 to 9 onward. Okay, so design requirement, design situation, durability, geotechnical design by calculation, design by prescriptive measure, load test on experimental model, observation model, geotechnical design report, also included in the Eurocode 7. Okay. So generally, okay, um, Eurocode 1987 provide 3 design approach to control the strength of soil and applied load. Okay, so there they implement the MNR. Okay, which is soil strength such as cohesion, friction angle, and dilatancy angle will be reduced using the partial factor. Okay. So A is more related to action, load surcharge will be increased with the partial factor. Okay, so this is reduced means that they divide, so increase means that they multiply. Okay. Okay, for the design approach, okay, they have 3 type of design approach. Okay, for example, for the design approach 1, they call as DA1. There are 2 combination from design approach 1 where they have combination 1, A1, M1, R1. Okay, so they have a design approach A1, M2, and R2. Okay, from what we have discussed previously. So we have M, R, and A. Okay, so each of M, R, and A have their own value to be included as a partial factor. Okay, so then we have design approach 2. Okay, so we need to use a combination A1, M1, and R2. Okay, so this is the design approach and with the coefficient number for a shallow foundation. Okay, so we may calculate first for design approach 1, combination 1. Okay, so we need to use the A1, M1, and also R1. Okay, for combination number 2, we should use A2, M2, and also R1. Okay, and for the design approach 2, combination of A1 plus M1 plus R2 should be included in the design calculation. Okay, so this is the number of partial factor safety. Okay, we may learn in the shallow foundations lecture. Okay. So A is referred to the action, M is referred to the material, okay, S is referred to resistance. Okay, so we have the bearing and also sliding. Okay, for example, if we are discussing on bearing capacity, so we refer R1 as bearing. Okay. Then we have design approach 3. Okay, A1 or A2 plus M2 and R3. Okay, so there are design approach 3. Okay, combination are denoted by A, action for effect of action, M for soil parameter, and R for resistance. Okay, they are selected according to the use design approach. Okay, however, formulation case, okay, we only use design approach 1 for STR and EQU in the design. Okay, so means that for Malaysian case, we only refer to the design approach 1. Okay, why we use only design approach 1? Okay, again, because we are refer to United Kingdom, so that's why we only use design approach 1. Okay, so this is the combination of design approach 3. Okay, either A1 or A2 will be used, plus M2 and also plus M3. Okay, so it means that for the design approach 1, we need to have two calculations. Okay, and both of the calculations should satisfy with the ULS, which is greater than 1. So we need to calculate for combination 1, and then need to calculate for combination 2, and then compare with the value, the ratio value, either it is greater than 1 or not. Okay. Okay. So this is the list of the country with their design approach. Okay, as I told you, okay, because Malaysian is referred to the United Kingdom. Okay, so that's why we only consider the design approach 1 only in our design. Okay, so there are some country, okay, using the design approach 2, and I guess majority of the country are using the design approach 2, and only one country using the design approach 3. Okay, so there are some country either using design approach 1 or 2. Okay, and there are some country using design 2 or 3, and only Ireland or Czech using design approach 1 or 2 or 3, and while the other country are unknown, perhaps they use their own design, what we call design standard, or they only refer to the CEN, or they have their own design approach. Okay. So what combination of partial factor to use? Okay, combination 1 involve the consideration of the factor, action, unfactor material and resistance. Combination 2 consider unfactor action, accept unfavorable variable action and factor material properties. Difficulty arise with the application of numerical methods such as finite element in the assessing of ultimate state. Okay. However, nowadays there are a lot of software or numerical method include the application of the EC in their design. For example, Praxis also they have the EC based on the EC design. Okay. So in this case, the factoring of source strength or stiffness can lead to the generation of inappropriate mechanism in the analysis. Uncertainty can also be experienced in assessing slope stability, where it can be difficult to separate favorable and unfavorable action, and in the design of design anchor, where the design and execution could provide conflicting advice. Okay. So stability state are usually expressed by adopting unfactored action and material property. Okay. So in this area, numerical analysis provide is useful for GC2 and GC3 projects. Okay. So normally for the numerical tools, they look the product, the output is on deformations. Okay, so that's why stability state are usually assessed by adopting unfactored action and material properties. Okay. So national choice is permitted in the use of design approach for STR and geo limit state. As indication in table NA1, only design approach 1 is to be used in Malaysia. Okay. So after this class, I will show you the Malaysian standard. Okay. So the table NA1 of this national, in the annex list the clause in national standard. Okay, where the national choice may be exercised in respect of factor value for design in Malaysia. Where choice apply, table NA1 indicates where value are given or state value to be used or prescribe the procedure for specifying the factor. The value given in table in Annex A of this national annex replace the recommended value in Annex of Nation EN 1987 Part 1. Okay. So Malaysia, okay, so Malaysia practice use the design approach 1. Okay. Other than pi anchor, use combination of 1 and 2. Okay, for axial load and pi and anchor, they use this combination A1 M1 R1. Okay, A2 plus M1 or M2 and R4. So we may learn in the deep foundation. Okay, where M2 is for calculating any unfavorable action such as negative skin or transverse loading. Okay, refer only to okay. Approach 1 based on the nation annex. Okay, so this is the list for all. Okay, deep and also shallow foundation. Okay, so this is what we call, this is the A. Okay, while this is the M, while this is the R for shallow foundation. For deep foundation, anchor, retaining wall and slope. Okay. So this is for to be used for combination 1, and this is to be used for the combination 2. So M2, although it is also rely on the condition other than slope and embankment, we use the M2. Slope and embankment, we use the M2 asterisk. Okay, so R4 is more related to the SLS. If we consider the SLS, so we use the R4 here. If you are not consider the SLS or the deformation, so we use the R4 in this column. Okay. Okay. So applying for inverse load, okay, in design situation where the ground strength act in unfavorable manner or drag or heave on pipe, the design value of unfavorable action may be obtained by the following method: applying the inverse set of M2 set of partial action factor to characteristic unfavorable action. In applying the inverse of the M2 set of partial material factor to be characteristic material strength to obtain the design strength and hence the design unfavorable action. Okay, so this is just explanation. Okay, when we are dealing with this situation of down drag or heave. Okay, however, we will not discuss in detail in the deep foundation for this part. Okay. So recommended value for partial velocity of negative skin friction. Okay, so this is the value if we are dealing with negative skin friction. Okay. Okay, so means that this negative skin friction should be included in the design as a positive value, as a additional load value. Sorry, I have a call. sorry. Okay. So this is for the negative skin friction. Okay. So again, I also will not discuss this in for under the pile foundation. Okay. So just to uh, have general explanations. Okay, on what will be the partial factor safety to be used. Okay, under this negative skin friction effect. Okay. So then there are a model factor, okay, they call as MF, and this is used for the what we call for the pile design. Okay, so we may look on this model factor in the design of the pile. Okay, so the value is around 1.2 to 1.4. Okay, so it depends on what uh, characteristic, okay, of the designer, okay, documentation, okay, whatever testing that we use. Okay, for example, if they carry out a maintain load test, so means that the confidence level is high, so the model factor has been reduced to 1.2 compared to we only use a site investigation result, and then a very experienced designer, so we just put as 1.4. Okay. So okay, this is the flow, okay, for the design value of action. Okay, starting from the characteristic action. Okay, so apply the factor. Okay, then they will we come up with the representative action. Okay, and then apply the partial factor safety. Okay, then we apply in the design action. So then we get the design effect of action. Okay. So so this is the summary of the technical design by calculation. Okay. So we have the representative action. Okay. So then we have a characteristic material properties. So should be divide with the coefficient or the partial factor safety, while for the action should be multiply. Okay. Then we obtain the design action, then design material properties. So should be included in the geotechnical design analysis. So from there, we obtain design effect analysis, ED, and design resistance. So the design resistance should greater than the design effect analysis. Okay. So the detailed discussion we may discuss on next class under the shallow foundation and also under the deep foundation. Okay. So I guess that's all for our today class. Okay. So I will upload the recorded video, okay, right after the class, after I receive the content from the Webex. Okay, so just a brief explanation on just to show you what we the Malaysian standard. Okay, so this is also where we include in your e-learning. Okay. However, it's better to get the full version of Eurocode, okay, 7, and then do a comparison. So this is the Malaysian Standard Annex, okay. Okay, so this is the table that NE1, okay, provision for this annex related to clause in when national choice is to be exercised, okay. So this is the subclause which is uh, they discuss on all these features and provisions. Okay. Okay, so this is section discussed on the pit. It most probably is different with the one that discussed in the Euro code because we have different type of pits. Okay, so this is the all the value. Okay, for the partial factor for soil. Okay, okay, so this partial factor for STR and geotechnical limit state. Okay, so this is for action, but this is for soil. Okay, this is for the resistance for the shallow foundation, but this is for pile. Okay, so it depends on the type of the installation. We have here continuous flight auger. This is bore pile, and this is for driven pile. Okay, this is for the pile foundation based on Z. They use the zeta. Okay, based on the number of static maintain load test. Okay, so this is based on the ground test. So for example, if we have more, we have a lot of what we call as maintain load test. For example, greater than 5, so the zeta value is equal to 1. Okay, if we have less, so we need to divide, or we need to apply 1 point, we need to divide with 1.4. So it means that the confidence level is increased where we have more data, okay, from the maintain load test. So similar to the ground test, okay. However, the ground test is not as accurate with the maintain load test. Okay, so this is dynamic impact test. Okay, this is for anchorage. Okay, so I have stated before it's not applicable in Malaysia, so we need to refer to the Euro code. Okay. Okay, so this is for the UPL problems. Okay, this is for the HYD. Okay. So this is a discussion on the model factor for the pile design. Okay, so in here, this is the reference use. Okay, and this is the name of the member of technical committee. So we have here Prof. Ramli and Dr. Jamaluddin from the academician part. So the rest is from the authority and also from the IEM, okay, or from the what we call from the consultant, okay. Okay, so that's all for today. I will upload this Malaysian standard as for your reference only, okay. So we meet next week, okay, same time, okay, to discuss on the shallow foundation. I will upload the notes, okay, for the shallow foundations before the class, okay. So that's all. Assalamualaikum and good afternoon.
Thank you, Doctor.